code is 493, and heading of this problem is reverse pair. And yeah, so this, how do you receive this reverse pair? So something is like, okay, so let's go to the first first try to understand the problem statement. Date is today like 4th March. Okay, so this is okay. Now, yeah, so let's make little light condition would be better. Okay, so yeah, I think it's now visible. And yeah, so let me try to understand the problem first. Okay, so reverse problem is like reverse pairs. So in this problem, like a question is to find the all such pair. So given integer array nums, return the number of all reverse pair in the array who have two attributes who are satisfying two conditions. And the condition is, so I have to return all such pairs of index. So you have to find all pairs of I comma j in such a way that their attributes they will follow such that they will follow the two below mentioned condition, right? Condition, and they are like 1. So 0 is less than equal to I is less than j is less than nums dot length, and second is nums of I is less than not less than, it's greater than 2 into nums of j. Okay, the condition, let me repeat again. Condition is something like I is less than j and nums of I is greater than 2 into nums of j. Okay, so you have to find all the such pair, correct? Now, okay, to understand better, let's go to the few example here. So example 1 is you have a given input nums which is 1 3 2 3 1. Okay, so this is the array having 5 element, and so how do you find it? So the brute approach is, I will put one pointer here, I will put one pointer here, then I will start from here. I'll check 1, is this? No, so it is not following, right? I will check this. Okay, order of pair doesn't matter. Is there anything? Return the number of pairs in the array. That was not mentioned, that order of pair matters or not. But for now, I'm just trying to understand. Just understanding it doesn't matter. Let's assume that this does not matter. And in that case, I have a P1 pointer and P1 pointer P2, and I will compare. Is this following? No. So I will switch to P2 here. So 1 and 3. Is it? So index by 0 is less than 1, 2, 3. Yes, it is. So this is condition met. Then value is greater than 2 into 3. Is it? No, it is not met. So the condition is not met, and so this is not the right. We are not finding anything right here, right? So let's not make sure that this is not the case. Okay. Then you go to the here, go to next, check it. No, same way. No. So this is not the case. Okay. So I have done with this. We could not find it. Now I find it here. 3 and 1. So 1 index is 1. 1 is less than 4. That's correct. 0 1 2 3 4. Yes. 1 is less than 4. That's correct. And 3 is greater than 2 into 1. This is also correct. So both condition is correct. So 1 comma 4 is the one index you found. One pair of index you found, which would be your answer. Okay. So that thing you found. Then again we will search. We already found everything here. So then 3 and 1. Okay. 3 3 no there is no possibility, and 3 2 is also not possible. Then 2 1 is not possible. Then again 3 and 4. 3 and 4 is the condition. I believe 3 is less than 4, and the value, this value is also 3 is greater than 2 into 1. So these both conditions are correct, and then I would say that this is also your solution. So these two solutions you will found. So answer would be 2. Answer would be 2, and pair is these two, 1 4 and 3 4. Similarly, you have example 2 also, and you will see that the same way you will get the answer. So in my opinion, like brute force, which will give you order of n square, right? Time complexity is order of n square, and the space complexity here is order of 1, because I'm not taking any extra space as such, right? But if you look at the constraint, now let's go to the constraint area. So in constraint, you can see that n is almost 5 into 10 to the power. So constraint here is n is 5 into 10 to the power 4 less than equal to 1. Okay, so on the higher node, this order of n square is equivalent to 2.5 into 10 to the power 9, which is really worst time complexity, and it is not permissible. So this problem definitely not a brute force solution. Okay, now what you will do next? So trying to find the pair is not optimal way you are doing in brute force. So try to find some way in which you will able to find these pair, like these two pair index, in such a way that it will cover within the time complexity either order of n or order of n log n, right? So that is the best way you can achieve. So let's go to, let's dive a little deeper to understand some better approach. Okay, so the next thing is, let's discuss the improved approach. The first approach we already discussed, that is the brute force approach. But the second thing which I am looking for right now is improved approach. So what exactly we have to do? Let's go to the writing pad. So on writing pad, let me share you the first half I'm selected. So in the first half, I will try to give you intuition. So what is this intuition here? So let's try to find some intuition here. So in this problem, what exactly have to do? We have to find pair index from given array. Find pair index from given array such a way that the first thing is your first index I should be less than position j, right? Index j. And that is giving me some intuition. So the first condition is to met I is less than j, right? And if you little deep dive, can you think about any sorting logic where you can do you are intuitively doing this thing only? And I think if you can think a little more, then you will realize that in divide and conquer approach, we are always doing this thing only, right? So what you are doing in divide and conquer, you have a set of range, say for example start and end. Now you are dividing this into two halves, but always remember, whenever you are dividing two halves, this first half has also same thing, right? So anything which is from left side in first half is always less than right side of the first half, like that way, right? So divide and conquer itself is fundamentally following this approach, one thing. Another thing is, if you remember merge sort, in merge sort you are basically dividing your range in half and halves, like that way. You are continuing your breaking down into small chunks until this reaches to some level where you have only one element left, right? After that there is no division possible, so then you will stop over there. That is what you are doing, right? If you remember, this is what you are doing. So that's why fundamentally merge sort, quick sort, these are the sorting based on divide and conquer. This is one thing. Another thing is, in the next requirement of this problem, there are two requirements, right? If you remember, one is this, and two is your element nums I must be greater than 2 into nums j, right? And if you analyze little more or deep dive little more, then you will see that in merge sort we are merging the element by this sorting logic only, right? So but the sorting criteria in merge sort, definitely it is only like this value should be less than this value if it is increasing, if decreasing this value is greater than this. But here there are certain different things. Here it is saying that you have first value which should be greater than 2 into second value, but still this is the same constant which we are following in merge sort. So fundamentally this is the problem of merge sort. So your job is now, so you found the pattern, right? You found the pattern logically, intuitively, you have developed your concept where you are now very much sure that this problem is solved by merge, will be solved by merge sort. Now let's move to the any doubt you have. Let's try same thing on your example. What I am saying that let's try the same thing while merging. You just try it, right, on the your example. Let's do it. Take one example, very simple example, to try to divide it, how you can fit this in the merge sort. So let's say you have a given array, and that is the same example which I discussed earlier, 1 3 2 3 and 1, right? So this is the array. Now what I'm saying that you just use this example to first divide and conquer. You just break from here. So this is your left part and this is your right part, okay? Right sub array and left sub array. Then again you go back and divide this left half, then you just divide again this part. Okay, and so this is your left part and this is your right part. Okay, again you go here and divide. This is your left part, this is your right part. L R R like that. When you reach like bottom, now there is no further division possible, right? So what you do here is from L and R you compare and check, do we have, so index comparison, like this index less than this index, yes it is correct, but this index and this index are, so let me change the color. So okay, so I picked the another color, and now I'm saying that your first target is to compare these two, right? So you compare it index wise, yes, index I is less than j, this is correct, but nums of I is greater than 2 into nums of j. Can you verify that? Are we satisfying? So 1 is greater than 6. Is it okay? No. So this is not the case. So you will not get, you will merge it, but you will not get anything out of this array, any answer in your like answer bucket, right? No valid answer in your answer bucket. So this is not producing any. Now again this. So this, now this left and this right, compare here. So what you do here, again you compare these two, then compare these two. So again you will see that this is not going to produce any result as such, right? Then there is this one and this one. Now let's see here, this is the left part. Now go to the right part first, this part. Now this part you can see that 3, so this I is greater than j, yes it is valid, but this nums I is also greater than 2 into, sorry, I is less than j, and 2 into nums of j, right? This is also true. So you found the one candidate. So one candidate for you is 3 and 4. These are the pair which is producing the result. Now you found this. This is your merged array, merged half, right half, and this is left half. Now again you compare these two. No. Are these producing? No. Are these producing? No. When you got this and this comparison, you will find again, right? And so the same rules, this, because if you remember, these two numbers only was the valid, here also 3 and 1, so the same number, and that's why this is also another candidate of your answer, and these two are your answer, final answer. So if you look at the problem, it is exactly the merge sort with small modification, small tweaking, right? And that is what I was telling you in when I was discussing about like how you have intuition, what kind of intuition you are getting from your problem statement itself. That's why this is the way you will understand it, and this is the way you should work on the problem logical derivation, right? So all right guys, so let's continue for 9.3 problem, and the problem I already explained you by now. Example is already clear, constraint I already told you, and we have to look around, like we already decided the approach. So an approach wise we have to adopt the merge sort only, right? So approach we finalized, which required here is to use customized merge sort. Okay, so let's try to understand this. So so how do you solve this problem? Okay, what precautionary? So merge sort have no issue, right? Merge method only required. So where you need customization, especially in merge method, you need to customize. Why? Logically, how this merge sort happening actually? So merge sort process is there are two-step process, right? The step one is divide the problem, okay, and then step two is first step is divide the problem, and step two is merge the division on the basis of predefined order. And how you will deal with the new requirement. And here these are the standard merge sort requirement. One additional requirement here as a step 2 subpoints A, just like that. This additional subpoints required here because this method need, and this method is you have to find the count. You have to find the count of pair of index which is going to give you the required pair. What I'm looking for, you have to find the count of pair of index which is going to give you the no, not like that, sorry, just hold a moment, just erase these things, not required. Okay, so actually you want the pair of index where your requirement here is you want the pair of index in which value at first index is greater than value of second index and 2 into, right? So 2 multiplied by value of second index. So this is what you should do in your merge sort additional step. And you just calculate as many as possible pair inside your merge step. And how you will collect it, because merge step is called for all the division merges, right? So how do you make sure that all collection will get reflected after this method call? So for that purpose, you have to call the you have to pass one additional parameter. You have to pass one additional parameter as reference of something like count or something. Count as a reference you have to pass in this merge method. This is the additional parameter from the normal merge sort. Okay, and inside that you have to just calculate all the possible pair of index which will be value of that index, first index, would be greater than 2 into value of second index. So you have to find the such all pair in your logic. That's it. And once you find it, done. So this is what you're supposed to do inside the modified method. Okay. So I think now I have explained you everything until now, and then please take like time complexity and space complexity is something like order of n log n and order of n. I can write also, but otherwise like time complexity and space complexity. So time complexity of this approach, time complexity is order of n log n, and space complexity is order of n. So these are the time complexity and space complexity for your purpose. That's all. All right, let's move to the ID now to complete your code. Now the point is, how do you make a merge sort, right? If you remember the merge sort, just give the scale. I'm just preparing, like if you remember my all 4 steps, the 3A, which is the third A, right? This is the third A step where I need to prepare the skeleton of our implementation, Okay, so a skeleton here is how to build the skeleton. So in this approach, you have to create a merge sort. Okay, so you have to create merge sort void. The name is merge sort, and I will pass here. Usually, if I'm a C programmer, I usually pass int array. But in case of you are working on C++ domain, you should always write instead of array, you should use vector, right? So int low, high, and one more parameter I am going to introduce here, the count, int ampersand count. This parameter is for counting the pair. So this is like that. Okay, and so briefly the structure would be like this. Now I would say if low is less than high. This is very standard algorithm of merge sort. Okay, if low is less than high, I will create. So I will define mid first. Okay, so and then I will create mid is equal to low plus high minus low divided by 2. And yeah, so this is like low by 2 and high plus high by 2. So that is what theoretically what you want to do. Mid is like low plus high divided by 2, right? To avoid this overflow, I have to write it this way, right? This is one of the good way to avoid overflow. Okay, so that is what we should do. And then after that, your call is just like merge sort. So you are just going for division step now, right? Divide and conquer. That is the logic. Algorithm is based on divide and conquer. Okay, so merge sort, and I will pass it here array, no issue. Then low would be in case of low, and here is mid. Okay, and then your count would be a count only. Okay, so this is merge sort. Again, merge sort would be array. Instead of low, you should call mid plus 1, and high is high. Okay, and count is count. Okay, and then the third step would be merge. This is inside this block only. Merge of array. I have to define somewhere signature, but I'm assuming that signature is defined. So this is something like low, mid, high, and array. So this is the defined structure of your merge sort, right? And then finally you have to write your merge method. So so this is one. And another method, which is this is again a void only. and then this is merge, and I'm passing it like vector the same way, this, then I have low, I have high, instead of first pass mid, I have a mid. Okay, so just erase it. So int mid and int high and int array count. This is your signature for merge method. Now this method need to be customized, right? The customization would be like, if you remember the general thing, how you are doing the merge, what you are doing in the merge sort. In merge sort, you are creating one temporary array, right? One temporary array, and then you are trying to iterate from low to mid for one index, for one half array, first half array, and similarly from second half you have to start from mid plus 1 to high. Okay, and you need to compare these two values. If they are, so position from any index from the left half and any index from the right half, compare it, and if both the given constraint which is asked in problem is met, the first constraint is already met, first half index is always lesser than second half. That is very much true, already true. Only you have to check that your first half, your first value should be greater than 2 into second value. If they are following this, then I would say consider this one, right? Consider this as a pair answer in your pair. Like, consider this pair in your answer, right? That is what you have to do here. Rest all, like similarly, you should proceed for all the customization, and finally you will get the all the pairs count, and that's it. You have to return that value. Okay, this is the only required from this merge method in this scenario. So yeah, excuse me. This is you only need few lines, custom lines in this merge method. Rest all are standard approach method. Rest all lines as you will be implementing your merge sort. Be particular, then this is merge method. Okay, so I'm not going to implement merge method here. I am going to give you the custom steps which you need to add in merge method for this problem. Okay, so what I am going to do here is int j is equal to either you say low, so I would say low, and then for this j value would be j is less than equal to mid plus 1, not mid plus 1, is it mid, and then okay, so hold on like this. So hold on, you have to implement like this. Int j would be the counter, so I will see mid plus 1, and for int I is equal to low, I is less than equal to mid, and I plus plus. Okay, this is the one loop. Inside this you have to run another loop which is j is less than equal to high. High would be the index, last index, so yes, and you have to compare. What should you compare? Array of I is greater than 2 into array of j. Okay, so if both are correct, right, this and this both are correct, then I would say simply you have to increment your count. So I will increment plus plus count. Okay, that's it. So if this is done, rest all your merge logic. So I'm not going to touch anything about the merge logic here, right? I'm just updating my count. That's it. And that count would be your final count once you are done with that. This is the only modification you need in your logic. Rest all are you have to simply do as usual, right? As usual, what you are doing in merge implementation in case of merge sort. That's it. So let's move on to the ID quickly, because now it has become. So now let's go to the and just open this, and let's go to the array string, and then just create one file. The problem number is 493. Okay, 493, and what else you can do here? Reverse pair, just right. So reverse pair dot cp. Okay, so this is new file I have created. As per the sample code, I have to just copy the glue code here, right? So here is your glue code. Okay, so this is your file, and here you have to just do one small thing. Okay, now what I'm trying to bring here is the sample code for basic basic kind of understanding for merge sort, right? Because merge sort, this is very simple, and like intuitively you can see the merge sort code. Okay, so this is your yeah, so now you have to write just a custom step here. Okay, you have to do some custom step, which I already told you that you need to build now custom step, right? So how do you build it? How do you build it? Okay, so the custom step here is this one. Okay, okay, so this much is your original merge logic below. Okay, so now I have to write only the additional step which is required, so I will see this, not array nums. Okay, so I will put it nums. So there are two ways, either change array over there. Okay, anyway, so that part is okay. Now I have to see my audio. Yeah, audio is working. Okay, so otherwise I have to repeat again. Anyway, so that is okay. Now I have to add few steps here for my custom requirement, and that is something. Let's put a writing pad aside now. Let's write the code now. Okay, so what is that? Int j is equal to mid plus 1. So for loop, let's say int I is equal to 0, I is less than equal to mid, and then plus I. This is your one method. Another is while j is less than equal to high and nums of I is greater than 2 into nums of j. If this is the case, then you have to just increment count by 1, just iterate all the steps. All right, so the same thing, right? This many line only you have to add, the rest all are okay, I think so. And yeah, so this is the thing you have to do. And now you have to link your method from merge sort. How you do? You have two important things here. One is size, so I would say nums dot size. Okay, then the requirement here is pass the merge. Okay, so one requirement, another is count. So count is equal to 0. Now merge sort, yeah, so merge sort is there. Inside the merge sort you have to pass nums is there, then low is 0, high is ns minus 1, and then count would be this variable. Okay, now one important thing here to do is that since if ns is less than equal to 1, then simply return 0. If size is 1, meaning your array size is only 1, then there is no way to find the pair, right? So that's why this step is very unique. You have to add, as per constant, there is a chance that this nums has one element also. That's why this special case handling is required in this problem. Okay, now this, and then return count, right? This is what we're supposed to do. Anything else I left? I don't think so. Let's do it. Let's check your code then. Let's check your code on the portal. Okay, so okay, so how do you share it? I mean, okay, so this is like run, and okay, I hope this is TLE. So it means that I'm missing something. Yeah, so I'm doing this wrong. So j++. Okay, so runtime error. Okay, so I is equal to 0 to mid, and signed overflow. So this signed overflow, long. Okay, something is wrong. What is wrong? So in my case, my answer is 2, though its answer is 3. The first case is okay, but second case is y. So plus count. So yeah, this is wrong. You have to implement this way. Okay, to do one thing, I think that's why this is wrong. So this seems to be right. So what is wrong then? Nums of I, j is equal to mid plus 1. J is starting from there and it is going to up to this, then nums I, and if this, then I will count plus and j++1, okay, and rest all are okay. Then Uh, hmm. Mm, mm. So count is incrementing here, right? In this method also count is by reference only, and finally here nums is getting populated. Okay, so I'm not sure. Is this the so start from I is equal to low, that's correct, but it should not go to high. Okay, so it should go with like k values, because k I'm starting from 0, right? Am I? Yes. So I will see that this value would be k, not high. Okay, and then okay, just hold on. So simply no need to do this thing. If you have to just do, then m is equal to 0, m is sorry m is equal to 0, m is less than k plus m. Okay, simple. Let's write the simple logic, and then I would say m nums m, and int I is equal to low, so I will say I plus plus and m plus plus. Okay, so you don't need to do m, actually m plus plus is already there, and your job is to iterate from m is equal to 0 to m is case and I is like that. Okay, so run this. Okay, so something else is a problem. Let me try to fix it again. Stop the video for now. My improvement here, like if you look at the code, it is simply that earlier I was checking that if the num size is 1, then you have to return 0. No need to check, because if you go to the merge sort, if your num value is, even though you like do this like that way, or maybe does not make any difference here, which I was thinking that. So yeah, and eventually this is your simple code. So I usually do this way, then I am doing not this way actually, low plus, let's say high minus low, and then I would say okay, do one. So this will again help you to achieve better performance also. And then reverse pair count is perfect. Go to this, go to the merge method. Now when you go to the merge method, in your merge method I have only to do, this is my customization step, right? This is my custom step for this problem requirement. Okay, and these are the, below is the standard method of merge. Okay, and so this merge is anything, I don't think so. I have some problem earlier, and when I compare this, I was doing something wrong here. I was following, like I am just copying back into the value which is overriding the earlier value, which is not the right condition. So I have modified it now. Like I just have to copy between the all range from low to high, right? This is the actual range of array which need to be updated while merging. So that was a small mistake I did earlier, so I just corrected this one. And earlier I was counting here inside the count, so I just did like small things, like reverse count is counted outside. For better understanding perspective, you may do like this. That's the better way. And then just copy this solution and let's try it in your IDE. I think it will work well, and so I just tried it also. So let's submit this. Okay, thank you. Thanks a lot for listening me patiently, and I hope you have learned something from this problem. Thank you. Thanks a lot. Bye. Take care.